Hello friends, this is Praveen and today I am here with the chapter Force and Pressure. Have you ever tried to play with a balloon, rubbing it to your sweater and try to raise your hairs? How it is possible? Even ask a question that the earth is spinning so fast, then why do not we fly randomly? Or even the why does the moon go around the earth? Why not randomly? And have you ever seen a magician claiming that he has been sleeping on 1,000 bed nails? How all these are possible? These all questions would be answered in this chapter, force and pressure. So what exactly is the force? In science, everything has a definition. So force also have a definition. The force is defined as the force acting when by a push or a pull. So push is in the we are pushing it away from us, and pulling in we are uh, we are pulling it towards ourselves. So the force is technically defined as the uh, quantity to do work, and it is the push or pull. The SI unit of the force is Newton, which is denoted by the N. This Newton N is named after the scientist Sir Einstein Newton. Now we are going to learn about the magnitude of the forces. Consider there is a block here and we are applying a force here. The direction it would move is called the direction of the force. And if we have the two forces acting in the same direction to create a larger force, so there should be no any degree gap also. So they are all parallel to each other and acting in the same direction. So this to get the total amount of force applied, we sum that all. So when the two small forces are applied in the same direction, we get a larger force. And there could be another case when the two objects, one force is applying here and one force is applying here. So they are both are in the different directions, so they would cancel each other out, and their difference would be the force applied. And there could be any other one more combination that one force is applying here and other, so both are there in the different directions. So what will the force where will the block move? It would not move here or either here, it would move a slightly different, it would move here. So what if they are both forces are equal, they would move in the equal angles. So here is an equal angle, here is an equal angle, they would move in the center. And if the ratio depends on the ratio of the force applied. Now we are going to learn about the effects of forces. What a force can do. First, if there is a ball in the rest, we make it move by throwing it up. So that is a force. Examples of these are pulling a cart or even picking up a brick. So in which a body is in the rest, which means it is not moving, and we make it move. The second effect it could do is change their motion, just like it is moving in a constant speed or any speed. So what we can do is to make it slow. We can either apply a force to make it slow or go fast. Example of this is a ball. You take a ball is going, we can either stop it, make it go slow, or by throwing we can make it go even faster. The third effect of force is that it makes the object come to rest. Just like applying a brake in the car makes the car stop. That is another effect of the force. And the last but not the least, the effect of the force is to change the shape of an object. Just like making a dough of chapati can be an example of change in shape. Now we are going to learn about the types of forces. There are major two types of forces: contact forces and non-contact forces. What are contact forces? Contact forces are the forces which are act only when the two surfaces are in the contact. When the two or more intersecting surfaces are in the contact, they are called the contact forces. And non-contact forces are the forces which can be applied from a distance. They are opposite from the contact forces. There are major two types of the contact forces. These are muscular forces and frictional force. Muscular force. Muscular force is the force applied by our hands or muscles by human being or any other animal. These forces are also called biological forces. Example is hammering a nail into the wall by our hands. So we use our muscles, and the muscles is an example of a muscular force. Now frictional force. A frictional force is a force which acts when the two surfaces are in the contact, and when we move in the direction, it always opposes us, creating the loss of the energy or the force. To learn more about the friction, I will upload a video later. Now we are going to move out the non-contact forces. As I said, the non-contact forces are the forces which can be used, which can be acted from a distance also. Examples of these forces are magnetic forces, electrostatic forces, and gravitational forces. First, we are going to learn about the gravitational forces. As I asked you in the question, that what makes the people not go fly randomly in the space? Why we are stuck to the earth? This is because of gravitational forces. The gravitational was first discovered by the Einstein Newton, in which he said that every particle that may be a point mass attracts each other. These depends on their masses and the distance between them. So Earth is a large mass which attracts the all the another mass. If the mass is larger, larger the attraction force. And when we are just like this is a human being and this is the Earth, we are comparatively very small to the compared to the Earth. So our gravitation force of the Earth is much more than our gravitation force, and we go towards the Earth. But do we really attract the Earth also? Yes, we attract it very minorly. So this is called the gravitation force. And gravitation force. The gravitation force has to do with the mass. What is a mass? Mass is the quantity of matter. It is the amount of the substance made in the body object. So the mass remains the constant everywhere we go, because that is made up of our what is our body made up of? It is made up of the mass. So if you go at another planet, just like Jupiter, your weight would change. The weight is defined as the mass. Weight is defined as the mass multiplied the gravity. So what happens? There is a mass, and where how much the gravity pulls, that is your mass. Just like on the Earth, if you weight 60 kg, that is 60 Newton. The at the moon you will weight 1/6 of the weight you have on the Earth, that is 10 kgs. So the gravitation help us to determine our weight. The more the weight or more the gravity, more the weight you have. Now we are going to learn about the pressure, force and pressure. Force and pressure. Pressure. So what is the pressure? A pressure, we hear lots of terms that I have been pressurized. What is this pressure? Pressure, I give you a real life example to understand it better. If you have many choices to go, many doors to go, and somebody is forcing you to go anywhere, so you have less pressure because you have many ways to go. But if you have only one door and of man is pressuring you to forcing you to go there, so you have the larger pressure. So simply the pressure is the force per unit area, and it is given by the force is equals to pressure. Pressure is equals to force divided by the area. The SI unit of the force is Newton, as I told you earlier, and the SI unit of the area is meter square. So the area, the SI unit of the pressure is given as Newton multiplied by the mass raised to the power of -2. So, and this is also called as a Pascal. The Newton multiplied by the mass raised to the power of -2 is also called 1 Pascal. This is also named by the scientist Pascal. Now, there are two types of pressures: the atmospheric pressure and the liquid pressure. First, atmospheric pressure. Do you know that the atmospheric pressure, that it gives a weight of 2 tons of that is equals to 2 small cars. You can lift it easily if there were no atmospheric pressure with no difference. So you are carrying a 2 tons, means 2 small cars on your head without knowing it. If there were no atmospheric pressures, you can even easily carry the uh, small cars and another thing in your hand without making any difference. So do you this is equivalent to about 1 lakh of the Pascal unit, which is Newton multiplied with the meter square minus square. So this is, and in the liquid pressure, let's go. Liquid pressures apply to the all in the apply on all the directions. So to conduct this experiment, you take a beaker, and this which is open from the both the side. You can take a tube and apply a balloon below, and raise the give the water from the upside. If it moves down, that means the balloon is inflating. So this gives that a force is applied. This is the downward force. Does it also apply the force for pressure in the sideward direction? To conduct this experiment, you take a beaker, and which is hollowed. The tube is attached to the its side, and it is hollow. The beaker in the hollowed part. And when you apply the put the balloon and pour the water, you will see that the balloon also inflates. That is an example of the pressure is also acting in the sidewards. Now we are going to conduct an experiment to know more about the pressures of the liquid. You simply take a beaker or a plastic bottle and fill it whole. You simply have to do a mark on different lengths according in the straight horizon. So what you make a hole here, 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 and here. And I ask you question: where will the water flow the maximum? In the maximum direction, in the according to the surface of the ground. The correct answer is from the below, because it has all the force. That is this hole has only the pressure of this much of area. This has will go slightly more than the above one, because this has this much of the pressure, and this would go slightly more than the second one, because this has this much of pressure, and the last one, which is that the hole which is at the below, would go the largest pressure, because it has that much of pressure, and it would go the more further. So now we are going to learn about the applications of these pressure and force. Applications of these are: even your body blood, which is pumped by the our heart, requires a pressure. This creates a vacuum, which the heart gives a force to it, and this is applied to the smaller area to create a larger pressure. And even using a straw, what is you are using a straw? This is a beaker, this is a cold drink that you want to drink, and you apply a straw. So there is no pressure here. When you create a larger cavity in your thoracic cavity, it creates that a vacuum here, and this here is a pressure. So the pressure would make the from this the cold drink go to your to the mouth, and then you drink it. Examples of these more are squeezing a toothpaste, lemon, orange, etc., or even using a vacuum cleaner. So friends, let's summarize what we have learned today. We have learned today about the force. What are the forces? The forces are the push or pull. Then we learned about the magnitude of the force, that when the forces are applied in the same direction, the force became larger. To simply we add them both. And when they are applied in the opposite direction, that is moving in the totally opposite direction, then we take the difference of that. Then we learn about the defects of forces, what the types of effect it can create a force. Examples of these examples are make the body move, stop the body, change the motion of the body, and even change the shape of the body. Then we learn about the different types of the forces. These are contact forces and non-contact forces, which are more further divided into muscular force, frictional force, gravitational force, magnetic forces, and electrostatic forces respectively. Then we learn about the pressure. Then we learn about the atmospheric pressure. What is an atmospheric pressure? What is the liquid pressure? And then we learn about the some applications of the pressure. So friends, I hope that this video is helpful for you, and at the last, thanks for watching. Have a nice day.